Okay, we have reached a very important section of the semester, and that is chapter 14, section 1, greatest common factor and factoring by grouping. So before I begin, let me just kind of explain what factoring is. Okay, so what does it mean to factor something? Well, the easiest explanation I can think of is if you take a number like the number 15, the question is, can we break that down into two things being multiplied together? So we've seen this before. We called it a factor tree. Well, we know that we can go 3 times 5, that would give us 15. So each of these numbers is called a factor. And here 5 would be another factor. So it looks like we have 2 factors for the number 15. If we multiply those together, we get back 15. Let's do another one, 12. Well, for 12, we could do, let's say 3 times 4. So those would both be factors. You could also have done 6 times 2. That would have worked. So 6 and 2 would have been factors. So there's multiple representations, but the whole idea is that if you start with something, can you break it down into 2 things that when you multiply them, you get back the original thing? And that's exactly what we're going to be doing here. In this section, we're going to start out with something. Well, eventually our goal is to start out with something and to break it down into 2 things being multiplied. In other words, factoring. So before we can do that, we have to get a couple of things in line first. And this first definition is called the greatest common factor. So the greatest common factor of 2 or more integers is the greatest factor common to each integer. In other words, it is the largest number that divides evenly into all the integers. Okay, so for example, if we look at what is the GCF of 12, 18, and 13, what we're trying to figure out is the biggest number we can find that goes into all of these numbers. So what we could do is we could list out all the factors of 12 first. So we think of all the things that multiply to be 12, 1 and 12, 2 and 6, 3 and 4, these are all factors of 12, and if we list them out, there they would be. And if we do the same thing for 18, 18 times 1, 9 times 2, 6 times 3, those would all be factors of 18, so we could list those out. And then we could do the same thing for 30 and get all those numbers and list those out here. And if you look at these lists, we're trying to find the biggest number that appears in all 3 lists. So that's what the greatest common factor is, right? These are all factors. So we're trying to find a factor that they all have in common, but it's the biggest one. So you can see something like the number 2 is common, but it's not the biggest, it's not the greatest. So that's what we're trying to do. There's kind of an easier way of getting it. It's just thinking about all the numbers that divide into these and just trying to come up with one in your head that goes into both. You could say 2 goes into all these, but so does 3, and 6 would be the biggest one. So let's try an example. Okay, so the greatest common factor of the number 24 and the number 40. So maybe we should list out all the factors of 24. So 24, you can get that by 24 and 1. You could go like 12 and 2. You could do, 3 goes in there 8 times. 4 goes in there 6 times. And that should be it. So those are all our factors. We look at 40. All the factors of 40 are 40 and 1. 20 and 2. 3 doesn't go into that. 4 goes into it 10 times. 5 goes into that 8 times. 6 doesn't, 7 doesn't, 8 we already have. So these are all the factors, and we're trying to find the biggest one common to both. So the biggest number I find in both of these lists that appear in both lists is the number 8. So our GCF would be the number 8. So 8 goes into 24, but 8 also goes into 40. So that's the biggest number that goes into both. Okay, so how about this? 20, 52, and 32. So I'm going to start thinking about this. It's the biggest number that I can think of. I'm not going to try the list. I'm just going to try and think of the biggest number that goes into, well, you know what? Let's do the list. Okay, so what about 20? 20 and 1, 10 and 2, 5 and 4. Okay, what about 52? 52 and 1. Excuse me. 52 and 1. 2 goes in there 26 times. 3 does not go in there. 4 goes in there 13 times. You could use a calculator to do this. 5 doesn't, 6 doesn't, 7 doesn't, 8, 9, 10. No, I think that's it. So let's get the factors of 32. 32 and 1, 16 and 2, 3 doesn't go in there, 4, 4 and 8, okay, 4 and 8, and 5 and 6 doesn't, okay, so that's it. So what's the biggest number that appears in all of these lists? So of course 1 appears in 2's in all of the lists. How about 4? 4's in all the lists too. Anything bigger than that? 5, no, 6, no, 7, 8, 9. That's it, 4. 4 is the biggest number that we can divide into those three numbers evenly. Okay, so that's how we find the greatest common factor of numbers, but how do we find the greatest common factor for terms? Well, that's a little different. So here's our first example. If we're looking at these two terms, let's try and find the GCF, the greatest common factor. So let's look at the numbers first. So 14 and 49, we try and think of the biggest number that goes into both of those. And we can do that work on the side if we need to, break down 14 and break down 49. And you'd find that 7 is your GCF, your greatest common factor. Now, the difference between this and what we did before is now you have to look at the letters too. We have x to the 4th and x to the 7th. So think about it this way. X to the 4th means we have x times x times x times x. And then x to the 7th means we have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. So they both have x's in them. What do they have in common? Well, they both have 4 x's. That's what they have in common. So our GCF will include the 4 x's that they have in common. And then we do the same things for the y. We have 10 y's here, 10 factors of y, and 5 factors of y. So what do they have in common? Well, they have 5 factors of y in common. So they have a 7 in common, they have 4 factors of x in common, and they have 5 factors of y. So that is your GCF. Okay, let's look at this one. All right, we want to do the GCF for 3 different things here, 3 different terms. So let's look at the numbers first, 12, 24, and 18. The biggest number that goes into all those looks like 6. Yes, 6 is so you could do the list over here, 12, 24, 18, and then do your list, and then find the biggest number they all have in common. That should be 6. Okay, this one has 6 A's, this one has 3 A's, and this one has 8 A's. So what they have in common, or the most that they have in common, is 3 A's. All right, how about B's? This one has a single B, this one doesn't even have a B, and this one has 2 B's, 2 factors of B. So your GCF has to be what they have in common, and they don't all have B's, right? The one in the middle doesn't. So B cannot be in our GCF at all. So we're not going to put anything down for B. And now we move on to C. We have 13 of them here, 9 of them here, and 4 of them here. So what do they have in common? Well, they all have at least 4. So this would be our GCF. Okay, this one. Okay, so what is the biggest number that goes into all those numbers? Okay, so starting here with the numbers 30, 15, and 75. Actually, the biggest number that goes in all of them is 15. How about the M's? We have 9 M's here, 3 M's here, and 4 M's here. What they have in common then is 3 of them. For the n's, we have n squared, n to the 6th, n to the 3rd. So what's the most they have in common, n squared. And then finally p, we have a single p here. We have p to the 5th and p to the 7th, but they all have at least one p, so that is our GCF. Okay, skip this. I think that's a typo. All right, so now we're going to go and talk about factoring out the greatest common factor. So far we have not done any factoring. We're just practicing what it means to be a greatest common factor. Now we're actually going to do some factoring, and we are going to try and use what we know about a GCF. So here's the idea. Remember how earlier I said if we add the number 15, you want to break it down to be 3 times 5. Well, here we're going to be starting with this, and what we want to know is, can we break that down into be 2 things times one another? Well, the first thing we always do when we try this is we take a look at the expression. You know what, I think I'll leave that there because that's our goal, is to break that down. I'm going to take a look at that expression, 8x plus 20. And I would like for you to look at what the GCF is between these 2 terms. So what do those both have in common? Let's start with the numbers, 8 and 20. The GCF of that is 4, so I'm going to write down here GCF. Greatest common factor between 8 and 20 is 4. How about x's? Well, this one has an x. This one doesn't, right? So I have no common x's to pull out. So my GCF is this. So what you do now is you put your GCF here, and then you put a set of parentheses. This is very important. And what you're going to do is you're going to ask yourself, if you were to distribute this 4 through to 2 different things, because we started with 2 terms, what would you have to multiply 4 by to get back 8x? So what would you have to multiply 4 by to get 8? Well, you would have to do a 2. Well, that's not enough, because 4 times 2 is just 8, but you also need it to turn into an x. So you have to put an x next to the 2. And then you have a plus sign here, so you'll put plus. And now you ask yourself, what do you have to multiply 4 by to get 20? And we know that that's just 5. So notice what we've done now is we've actually taken this original expression and we have broken it down to be 2 things times one another. It's 4 times 2x plus 5. Again, distribute this through and you would get back the original problem. So the idea of factoring out a GCF means going through each of the terms and finding out what they have in common, putting that in front of a parenthesis, and then inside the parenthesis you're going to multiply through and try and get back the original expression. So let's try this one. So we look at these 3 terms, let's try and find a GCF. Okay, so in terms of numbers, let's see, 9 is the GCF. 9 is the biggest number that goes into 18, 27, and 9. What about x's? They all have at least one x, so that will be my GCF. So I'm going to put 9x, now pay attention here, I'm going to do a set of parentheses, but watch what I'm doing with this. I'm allowing myself enough space for 3 things here, and that's because I have 3 terms in the original expression. So now ask yourself, what do you have to multiply 9x by to get back 18x cubed? Well, I have to multiply the 9 by 2, and I need to multiply that x by x squared so it becomes x cubed. So if I distribute through here, we should get that first term, 18x cubed. Okay, now we move on to the next piece. Oh, the 9 went away. So now we want to be able to get negative 27x squared back. So what do you have to multiply 9 by to get negative 27? Well, negative 3. And then you want to turn x into x squared, so you're missing an x, you need an x. And now we move on to the last piece. We need a positive 9x. Well, what do you multiply 9 by to get 9? Well, just a 1. And what do you multiply x by to get x? Well, 1 again, but I already have a 1 there. So you can see if I multiply this whole thing through 9x times 1, I would get back that 9x there. So this is our factored form of the expression. Okay, for this next one, I think I'm just going to write the answer. and see if you can't get that yourself. 11, a to the 4th, b to the 6th, and then it'll be 2b cubed plus 5, a to the 4th, and then minus 3, ab. That should be what you get. Now, sometimes it might be necessary later to actually factor a negative number out of something. So for this, let's try and pull our GCF for this one. So let's look at our numbers here. We have negative 10, 45, and negative 15. What I'd like for us to do, first find the biggest number that goes in all of those, which I believe is 5. And then in terms of x's, we have 2 x's common to all of them. Now we could say that our GCF is 5, but we're actually going to try a negative this time. So we're going to put negative 5x squared here, parentheses, enough space for 3 things, 1, 2, 3, because we started with 3, 1, 2, 3. And now we just play this game. What do we multiply negative 5x squared by to get negative 10x to the 4th? Well, we have to multiply negative 5 by positive 2, that'll give us negative 10. And I have to multiply x squared by x squared to give us x to the 4th. Now for the next piece, positive 45x cubed, I need to actually multiply by negative 9, because negative 5 times negative 9 will give me positive 45. And then I also need an x because I need it to be an x cubed, but I'm starting here with x squared. And then lastly, I need negative 15. So negative 15, I'm going to do positive 3 here. And I need x squared to turn into x squared, but it already is x squared, so the positive 3 should just be fine. See if you can work this one on your own. We should get, and I want you to do a negative 7 on this one. And then a cubed, they both have in common. So I'm going to just write the answer, and I want you to make sure you can get this. There you go. That's what you should get. Okay, moving on. This part's a little tricky, all right? So I'm going to try and illustrate this a different way. If I wrote 8xm plus 3m, I think that everyone would agree that these both have an m in common. And so what you could do is you could say a common factor is m, then set a parentheses, and then inside here you do 8x plus 3, just like we did before. If you multiply this through, you get back the first piece, multiply it through here, you get back the second piece. So there's an m in both, so that m gets factored out in front. On this example, I want you to realize that the m is actually this x minus 5 in parentheses. So both of these terms, this term and this term, both have an x minus 5 in them. So my GCF is going to be x minus 5, but I have to put in parentheses. And then I'm going to set a parentheses here in enough space for 2 things. So the question is, what do you have to multiply this by, x minus 5, to get that? Well, the only thing you're missing is the 8x in front. So you just put 8x. And then what do you have to multiply this by to get this? Well, again, the only thing that's missing is the 3. So you put plus 3 there. And this would be your factoring out of a binomial. Okay, next one, I'm going to work through this one. So we have this and this, that's in common in both, so I'm going to pull that out front. And then enough space for 2 things, and then I just need to see what's missing. So I have a 6b here. The only thing missing here is a minus 9. And that is it. Okay, this last piece here, factoring by grouping, very important. It's going to come up. You've got to learn this process because it'll hurt you later if you don't know it. So factoring by grouping is a method that we do whenever we see 4 terms. We try this, okay? So we're going to try it if we see 4 terms. Now I want you to just follow me, see how this goes. So we see here, my first example, I have 4 terms. So what I'm going to do is I'm going to look at the terms right after the second term, right behind that x. I'm going to just slash this problem into two smaller problems. In this first problem, I want us to identify a GCF, and just ignore this, okay? So those both have an x in common. So I'm going to pull out an x, and then I have enough space for two things in here, and I'll wind up putting an x plus 5 there. So check, this distributes through, and that'll give us back this expression. Okay, so now what do? Well, then you're going to now focus on these two terms and pull out a GCF. So, and also you won't always want to put a plus sign here after that parenthesis. So now look here, what is a GCF here? You put y, because that's what they both have in common. Enough space for two things. What's missing here and what's missing here is an x and a plus 5. So again, checking, you can multiply this through and you would get back that. Okay, so now what? Well, this problem should look a lot like these problems, where they both had something in common. So we have the x plus 5 is in common, so we can pull that out front. Oh, come on. There we go. X plus 5. And then enough space for two things, because we had two things, one thing here, one thing here. This first one's missing an x, and the second one is missing the y, so plus y. And that is it. So if we were to multiply that out, we would get back the original problem. Okay, next one. Go here, two terms, slash it. On the first two, I can actually pull out a GCF of 4w squared, and I'd be left with 2w cubed plus 3. And then on the second one, notice that I can pull out a negative 5 out of both, and I would be left with a 2w cubed plus 3. So I'm not showing that work. I'm trusting that you have done enough examples that you can see what the GCF is of this, which is the negative 5, and then go ahead and put your parentheses and think about what you need inside that parentheses to get back that expression. And now, at this point, hopefully you see that these match. And so you write that down in parentheses. And then whatever was missing goes in the next parentheses. Like that. Okay, last one. Or actually, you know what, that was it. I think these, I'm going to leave these to you, and I'm going to answer questions when we meet to discuss this section. I think this is going to cause problems, I think, for a lot of people. But let's just see how things go.